I want to do an example of an iterated integral for you here. I have this integral here. It says integrate first with respect to x and then with respect to y. So with the dx on the inside, these are the limits for the x value variable, and the dy on the outside, these are the limits for the dy. So it's interesting when I look at these things at first, I think, oh my goodness, I got a polynomial times a trig function. I'm probably going to have to do an integration by parts here. However, it's easier than that because when I'm integrating with respect to x, it's like partial derivatives. I'm sort of doing partial integrals. I'm thinking of y as a constant here. So this isn't a polynomial of x times a trig function of x. This is just a constant times a trig function of x. So when I'm integrating here, with respect to x, I'm treating all the y's as constants. So this is equal to the integral from -3 to 3. I'm going to find an antiderivative with respect to x here. Well, the antiderivative of a constant with respect to x is just that constant times x. And then that y prime comes along for the ride, and the antiderivative of cosine x is sine x, right? So I'm evaluating this stuff now for x between 0 and pi over 2. And I don't need to do this, but I try to be very careful here because I've got two variables in here and I got to pay attention to what I'm plugging into. So I do write down that, hey, this is x is from 0 to x equals pi over 2. I do that for myself to keep from plugging stuff in the wrong place. I don't want to be plugging these values in for y because they're x values. So I still got the integral from -3 to 3. I'm going to plug the pi over 2 in. So I've got pi over 2 times y plus y squared times the sine of pi over 2. And then I'm going to plug the 0 in. So I've got y times 0 plus y squared times the sine of 0. And oh, life is good, isn't it? There's still a dy when I'm done here. Sine of 0 is 0. So this whole thing just turns into a 0. The sine of pi over 2 is 1. So this looks like here I've just got the integral from -3 to 3 of pi over 2 times y plus y squared. Integrate with respect to y. Well, I can do that. Actually, at this point, I could plug this into my calculator, but let's do it by hand. This is pi, here we go, pi over 2 times y squared over 2 plus y cubed over 3, and I'm evaluating that whole thing between -3 and 3. Notice here I didn't say y equals and y equals because there's only one variable left. There's no confusion up here. I might have been confused, so I did tell myself which variable I was plugging in. So anyway, we plug in here, and I've got pi over 4 times 9 plus 27 over 3, and then minus pi over 4 times 9 minus 27 over 3 for a grand total of, well, those go away and these double on themselves, so 9 plus 9 is 18. So it looks like I have an answer of 18. So the volume represented by this by this iterated integral is equal to 18 cubic units, whatever the unit on x and y are there. So there you go. You do one, then you do the other. It's just like doing partial derivatives when you're doing that first integration, right? The variable I'm integrating with respect to x, so the other variable is a constant.